Hey folks, I want to pledge to you that I'm going to do everything I can to help you understand this. I'm available after school, I'm available before school, during tutorial time. Unfortunately, I'm not here today during sixth period. In fourth period, we had a really good discussion, and Quinny wrote some notes on the whiteboard off to your left. So I'm going to try this a little differently. I don't have my picture on the screen today. I'm going to try to record some things using my ViewSonic, but I'm going to do number 8, your first homework problem, with you and try to really break it down step by step. And 8 is just like the last one on the test that we took on Friday, and some of your classmates are taking right now in class. So the bad news is we didn't do that great on the last whatever it is, number 10 on the test. I think it was number 10. I don't remember what number it was, but it was the last one. And this is going to be in an effort to kind of reteach this concept, and then we'll retest on it. So tomorrow I'm going to hand the test back to you, and we're going to try the very last problem together. Well, not together. You'll have to do it on your own, but everyone's going to do it at the same time, like a second attempt. Okay, that's what I meant by that. So let's get to it. So this is number 8. I want you to have the book open to page 248, number 8. And you've got this function right here, which is x to the 4th power. And then this one is 8x. And so you graph the two functions. And Quinny was our recorder over on the whiteboard. He says, reflect over the axis. So in this program it's called mirror. And so I select my object that I'm going to reflect over the x-axis, not the x-axis, the y-axis, excuse me. We're going to go over the y-axis in this problem. And that's our first step, to kind of visualize what it would look like flipped over the axis. So back, in our notes here, you of course, are doing this without help from Rhino. And so you would just try to draw the picture. So it might help to put a point down, like this point right here, and then try to draw, a straight line to that point. I'm going to cheat a little bit here. I'm going to grab my line tool. I'm going to draw a straight line to there, and then I'll draw the curve section. I'll try to draw the curve section up like that. And so that's my step 1. So in your notes, I want you to do this. Put down step 1, reflect over the axis. Okay? So that's what Quinny wrote over there, reflect over the correct axis. I'm reflecting over the y-axis because in our problem on number 8, this is on page 248. Page 248. Have your textbook open, please. Please do your best with Miss Moriarty. Don't hassle her. So page 248, number 8, and I've reflected it over the y-axis because that's what it says to do in our problem. We're rotating about the y-axis. So I usually draw a little arrow there to remind myself, hey, let's go over the y-axis, okay? Step 2 is to find the bounds. He's calling it the bounds. So, what are the points of intersection on the original function? Don't mess with your reflected image, just the one that you have over here, on the first quadrant. So this is 2, 16, and this down here is 0, 0. And he showed a little work with that. So on step 2, what he did was he set the x to the 4th over there equal to 8x. So he did 8x equals x to the 4th. And you can see pretty clearly that if x equals 0, plugged in here and here, then we get 0 equals 0. So that's definitely one of our points, but that's this at the origin, right? That's the point at the origin. So what I need to do next is, now that I know 0 is one of my answers, I'm going to take 8x and I'm going to divide it by x, and I'm not letting x equal 0 now because I'm dividing both sides by x because I've already found the x equals 0 solution right here. And so now I get 8 equals x cubed, and I take the cube root of both sides, and I end up with 2 for my other x value. So my other x value is 2, and that means that if I plug 2 into my function, either one of the functions, so 8 times 2 is going to give me my y value, or my y is equal to 16. So this point right up here is 216. Okay, so check mark on my bounds. Step 3 is to Draw a cross section. So what I'm going to do to help us understand the cross section a little bit better is to look at it in 3 dimensions. So I'm going to turn on our whole shape that's been revolved around the y-axis. So we can kind of see, okay, there it's got like a place where you could pour water into. It's like a cup almost, right? And then what I did in our lessons before is I said, let's contour this thing. Oops, contour. And then you select the object that you want to contour, and we select the axis that we're going to contour about. So let me just come back over here to this screen, and I'm going to try to go right up the y-axis. And then I'm going to cut it every 1 centimeter. So I'm just going to hit enter. And now it's cut the figure into a bunch of little circles. And actually they're washers, right? So I can see where those washers are in my drawing here on the screen. Let's take them out though of the picture so we can see them a little bit better. I'm going to rotate them around a little bit more. Okay. Now I'm just going to grab one of them. Okay. So that we're not distracted by all of them at the same time. And let's rotate around and let's just look at what one of them would look like. Okay. And let's zoom in on that guy and get the gumball off. So now we've got this washer shape. That's why we call this a washer. And what we need to know in that washer is what is the big radius and what is the small radius. So let me go back over here and I'm going to take a picture of that and I'll drag it into my notes. So I'm going to come over here, I'm going to get a picture of my washer and I'm going to find it in my notes. Okay. And let's zoom out a little bit here and we'll put it down. We're going to move this guy. We're going to move this right down below in our notes. And so my washer shape, okay, so my step 3 says draw the cross section. Here's my cross section. And, you know, you might want to draw them kind of in one of the shapes. You know, actually, like, let's take this guy and let's slide it back in there. Okay, let me zoom out here for a second. So you might want to try to draw one particular cross section. Well, you need that part too. You need the center circle. You know, and try to visualize what that looks like. So like on your 3-dimensional drawing up above, what I'm saying about that is you might not see that that's that washer shape. So you try your best to see what the shape is by drawing in something with, you know, maybe some hidden lines. You do something like that. And hopefully you can see that it's a washer. That's our shape right down below, right? So what do we need to do next? We need to figure out this distance right out to here, that big radius. If I come straight down to the x-axis, I'm going to put a little tick mark right there, and I'm going to call that x with a capital R. That's my big radius all the way out to the circle, x sub capital R, right? And the area of this region right here, let me shade this in red. This area right here, this washer shape, is going to be pi x sub big R squared minus pi x sub little r squared. So in step 3, where he's got draw the cross section, we've kind of blown right past that. So let's put that down. Draw cross section. So cross section, okay. And then in step 4 on our whiteboard, so if you're watching this at home, like you were absent or you were like during 4th period, you were making the test up, he's got in step 4, find the area of the cross section. So that's what I'm doing right now. Find the area of the cross section. That's what I'm trying to do right now by doing pi big R squared minus pi little r squared. So it's the big circle minus the little circle inside, right? So here's our little circle. Now I haven't put the x sub little r in there yet, so I'd have to draw like another little radius right here, and I'm going to call that x sub little r. So let's change colors here because this is going to get a little difficult to draw up here on the screen. Here's where my x sub little r would be, right there. So that's my x sub little r in red. Okay, now what's the problem with having my equation just like I've got it? Well, the thickness of our washers, let's go back over here for a second. The thickness of this washer is super, super thin, right? So that little circle and this little circle right here, I need to move that guy back over, okay? Each one of these guys is super, super thin. But if we gave it more thickness, we would want it to go vertically a little bit, right? So, you know, I could try to do that real quick. Let's see if I can make that happen here. So I'm going to try to grab that guy, and I'm going to say extrude curve, and I'm going to just make it 0.1 centimeter tall. Okay, so now it's got a little bit of thickness to it. You see that little thickness it's got in there? So if we slid that back into our shape, you can see, I hope, that that's a dy right over here. In our drawing, we would have a little bit of thickness to it. And so that thickness is called dy. So right down here in my equation, I'm going to put dy down there because this part is the area. Okay, this is the area of the cross section. And this part is the thickness of the cross section. So now what I'm doing is I'm doing step 5. So this right here is my step 5, which is set up the definite integral. So I've got my area times my thickness. Now I just need an integral sign. And then I need some limits on it. And the smallest circle, and we went over this in 4th period and we went over it fairly slow, but it was still difficult to see. The smallest little circle would be right down there. It's like a little dot. Do you see that little dot right down there? So where is that at? If I grab that little dot and I slid it back over, that little dot is starting at 0. Where is the biggest washer at? Let's see if we can find the biggest washer. Here's the biggest, I guess, is like, where's the biggest? Big R, right? So it's right there. So let's look at that. How tall, how high did we go up there? We went up to to the 16, right? So we started 0 and we went up to 16. So you got to visualize, how are you stacking these things, right? How are we taking this guy and stacking them on top of each other? And so we'd go from 0 up to 16. So I'm going to go back over here, and I'm going to put my 0, and I'm going to put my 16 up there. And now I would look at my equation and say, wait a minute, I have x's here and I've got a y over here. They've got to be in the same variable. They can't be in x's and y's. So I've got a little bit more work to do. And so I look back at my equations up here, my 2 equations. One was 8x. So we had our 8x equation, and we had our x to the 4th equation. And I'm going to take those and I'm going to solve them for x. So let's do that real quick. We had y equals 8x, and we had y equals x to the 4th power. So to solve the first one, by the way, this is my little x sub r. This is my x sub r, capital R, right? And so I'm going to divide both sides by 8 on this one, and I end up with y over 8 equals x sub r, lowercase. And over here, I'm going to raise both sides to the 1/4 power. On this guy, I'm going to raise it to the 1/4 power. So I get y to the 1/4 is equal to x capital R to the 4th power to the 1/4 power, because that will just give me x capital R subscript. And then I've got a y to the 1/4 power. So I'm going to take this and substitute it in right over here, 0 to 16. And I'm going to move my pi out front. It's totally legal to move a factor of pi out in front of the integral sign. And then inside here, I'm substituting in what x sub capital R is, which is y to the 1/4 power. Okay, but I still have to square it. And then minus my x sub lowercase r is y over 8. And then that's squared and dy. At this point, we want to go to Desmos and we want to plug exactly what we got right here into Desmos, okay? Don't do any more algebra work because it was the calculator portion of the test. So I jam over here and I'm going to put in here integral from 0 to 16, and I'm going to put a pi out front, right? So pi out front, don't forget the pi out front. And then I'm going to go in here, and I'm going to go, I probably would switch it back to x's, but I think y's will work. So I'm going to go y to the 1/2 power, right? Well, let me switch back over here. What was it again? It was y to the 1/4 power, y to the 1/4 power. And then we're going to square that. So I got to get in there and go 1/4, and then we're going to square it all, right? So I close my parentheses, squared. That didn't work. Let me try that again. Let me get exponent. Let me try that. Control X. Cut that out of there. That out of there. Let's go back down here. Let's try it again. So Control V. Nope, don't like that either. It's not in the right font size. So let's see. Y to the 1/4 power. And then we're going to close the parenthesis, and then we're going to square it. Okay. Ooh, it's not letting me do it right now. So let's see if we can get over there. Come on. Y to the 1/4 power. And then we want to square that stuff. And then we're going to subtract. What was the rest of it? Y over 8. Y divided by 8. And then we want to square that stuff. And then we want dy. And yeah, that's what I was afraid of. Like when you have, oh, first we got a parentheses here. Parentheses around all that stuff. It just doesn't look like the right font size right here. That doesn't look right. So I'm going to delete it again, try to figure out what's going on. Well, there's a situation where just simplifying would help, right? So how about like right here, if we take that, take 1/4 to the 2nd power, it'd have 2/4. So that's y to the 1/2. So I'm going to put it in like that right here. I'm going to have y to the 1/2 power, or the square root, right? Y to the 0.5. Okay. So this is my volume right here. It doesn't hurt to simplify a little bit, you know, like I simplified right there, 1/4 to the 2nd power, right? So those two multiplied together give you 2/4. I hope I'm making this clear. I think you can do this. I need you to do the homework tonight, 8, 9, 10, 11. 11 is another one of these cross sections that is perpendicular to the y-axis. We're going to turn this in tomorrow for a little homework credit, and then I'm going to hand the test back. I'll take some questions at the beginning of the class, so we're making sure that this is all clear. Hey, thanks for watching my video. I appreciate it.